In the early morning of June 30, 1908, something came out of the Siberian sky with enough force to erase a forest and still leave behind a mystery. There was no famous battlefield, no great city, no easy photograph of a crater to explain what happened. There was only a remote stretch of taiga near the Podkamenia Tunguska River, a flash brighter than the sun, a wave of heat and pressure that flattened trees for miles, and witnesses who struggled to describe what they believed they had seen. Some said the sky split open. Others said fire rushed overhead. Many simply remembered the feeling that the world had lurched out of place. More than a century later, that feeling has never completely gone away. Because the Tunguska event was not only destructive, it was strangely incomplete. The violence was obvious. The answer was not. The known facts are startling enough without embellishment. Sometime after 7 in the morning, an object entered Earth's atmosphere over central Siberia and exploded in the air before it could reach the ground intact. The blast was so powerful that it knocked people down dozens of miles away, shattered windows, and sent a shockwave around the planet that instruments registered far beyond Russia. In the immediate region, forests were laid flat in a vast radial pattern. Researchers later estimated that roughly 80 million trees across more than 2,000 square kilometers were scorched, snapped, or thrown down. Yet the event left no obvious classic impact crater, no clean bowl in the earth announcing a simple meteor strike. That contradiction is what gave Tunguska its permanent hold on the imagination. The land looked as if the sky had struck it. But the ground refused to provide the neat evidence people expected. Eyewitness accounts remain some of the most unnerving pieces of the story because they sound like descriptions of a war before the modern age had fully prepared people for weapons from the sky. Settlers in the region reported seeing a bluish-white body or fiery column crossing the heavens. Some described thunder like artillery. Some said the horizon glowed and the air itself seemed to burn. One witness spoke of being thrown from a chair when the shockwave arrived. Others remembered a hot wind, then a delayed crashing sound that rolled over the landscape. What makes these memories powerful is not just the terror, but the distance between experience and explanation. Most people living through that morning had no reason to think in terms of cosmic airbursts. To them, it felt more like the sky had committed an act of violence and then withdrawn before anyone could understand it. Tunguska is also a mystery shaped by geography. If the same explosion had happened over London, St. Petersburg, Berlin, or New York, the event would have entered modern history immediately as an international catastrophe. There would have been armies, engineers, newspapers, photographers, and scientific commissions on site within days. Instead, the blast happened over one of the most remote inhabited regions on Earth. The taiga did not make investigation impossible, but it made it slow. Reaching the area required time, money, endurance, and a willingness to travel into terrain that was difficult even under normal conditions. That remoteness created one of the strangest aspects of the Tunguska story. An event large enough to flatten a forest and disturb the atmosphere across continents did not receive a prompt full scientific investigation. The explosion was immense. The first response was almost silence. There were historical reasons for that silence. Early 20th century Russia was dealing with political strain, distance, poor infrastructure, and limited capacity to chase a mystery in central Siberia simply because it sounded extraordinary. Reports filtered outward, but the event did not instantly become the kind of international scientific emergency it would become today. By the time serious expeditions reached the scene, years had already passed. That delay matters because Tunguska became a mystery not only through what the object did, but through what time did to the evidence. Fire, weather, swampy ground, falling timber, erosion, and simple biological recovery all worked against a perfect reconstruction. The site kept its scars, but not in a form that would easily surrender a single decisive answer. The name most closely tied to the scientific hunt is Leonid Kulik, a Russian mineralogist who pushed for expeditions into the region in the 1920s. When Kulik finally reached the area in 1927, what he found only deepened the enigma. The forest had not been removed in the way an ordinary blast might suggest from a distance. Instead, huge areas of trees radiated outward from a central zone, as if a colossal force had pushed them flat from above. Yet in parts of the central area, some trees remained standing, stripped and scorched but still upright, like blackened poles. That detail turned out to be one of the most important clues. If the object had slammed directly into the ground, investigators expected a different pattern and a more obvious crater. What they found instead suggested that the main destruction came from an explosion in the atmosphere, not from a clean impact into the Earth below. That was the first great twist in the Tunguska mystery. For many people, an object from space means a crater, buried fragments, and a seam that points clearly downward. Tunguska pointed upward. The devastation was real, but the signature implied that the object had broken apart or exploded before impact. In modern language, the leading explanation is an airburst, a cosmic body entering the atmosphere at immense speed, compressing the air in front of it, heating, fracturing, and releasing most of its energy high above the surface. That theory explains why the forest was flattened without an obvious giant crater. It explains why central trees might remain upright while branches were torn away around them. It explains the strange mix of heat, shockwave, and radial destruction. But even though the airburst theory solved the broad shape of the disaster, it did not settle the deeper question. What exactly burst over Tunguska? That question has never been easy because the object seems to have erased much of itself in the act of destruction. Scientists believe the Tunguska body was probably an asteroid or comet fragment several tens of meters across, large enough to release enormous energy but small enough to be destroyed in the atmosphere. Yet probabilities are not the same as proof. There is no single intact meteorite in a museum case labeled Tunguska in a way that ends the debate forever. Researchers have identified microscopic particles, chemical traces, and indirect evidence consistent with extraterrestrial material, but the event is famous partly because it denied investigators the satisfying simplicity of a surviving impactor. It arrived, exploded, and left a wound larger than its surviving physical remains. The wider atmosphere told its own eerie version of the story. In the days after the blast, unusual night skies were reported far from Siberia. Parts of Europe and Asia experienced luminous twilights and bright noctilucent conditions, as though fine material had been lifted high into the atmosphere and spread across a huge area. Newspapers commented on strange light. People reportedly could read outdoors late into the night in some places because the sky remained uncannily bright. Those atmospheric effects fit with the idea that the object disintegrated violently and injected dust or water-rich particles into the upper atmosphere. But they also contributed to Tunguska's almost apocalyptic reputation. The explosion did not confine itself to one forest. It seemed to leave a visible memory in the sky itself. Even the human stories around Tunguska are shaped by uncertainty. Indigenous and local accounts from the broader region include descriptions of fear, fire, heat, and shock. Some remembered reindeer killed or scattered, huts damaged, and landscapes transformed. Later retellings sometimes merged first-hand testimony with folklore, rumor, and interpretation. That mixture is understandable. When something inexplicable happens in a remote place, memory does not remain laboratory clean. It becomes social. People repeat what they saw, what neighbors said, what older beliefs suggest, and what later investigators ask them to remember. This does not make the witnesses useless. It makes them human. Their testimony preserves the emotional truth of the event even when some details blur. The sky became dangerous. The earth responded. And nobody nearby had a language broad enough to domesticate the experience. As scientific theories accumulated, Tunguska turned into a kind of test case for how modern minds behave when an event is dramatic enough to invite both rigorous study and wild speculation. The strongest explanation has long been that a stony asteroid entered the atmosphere and exploded several kilometers above the ground, releasing energy equivalent to many megatons of TNT. Depending on the model, the object may have been around 50 to 60 meters across, though estimates vary. This scenario matches the absence of a large crater, the pattern of fallen trees, the thermal pulse, and the shockwave. It also fits what modern researchers learned from later atmospheric explosions, including the 2013 Chelyabinsk event, which demonstrated on a smaller scale how dangerous airbursts can be even without ground impact. In that sense, Tunguska is no longer beyond science. But it remains beyond complete closure. The comet theory has also held on for years, partly because it elegantly explains some missing evidence. If the Tunguska body were composed largely of ice and volatile material, then much of it could have vaporized in the atmosphere, leaving even fewer recoverable fragments on the ground. That makes intuitive sense. It also helps explain why the scene looked so violent while still withholding solid chunks of impact debris. But the comet theory has its own complications. Researchers debating the composition of the object have pointed out that some patterns fit a denser rocky body better than a loosely bound icy one. Others argue that the observed effects could be produced by either class of object depending on angle, speed, and breakup behavior. Tunguska does not merely allow multiple models. It keeps them alive by refusing to preserve a final piece of evidence strong enough to kill the weaker ones. That refusal is why stranger theories have flourished around the event. Over the decades, Tunguska has been blamed on antimatter, miniature black holes, natural gas eruptions, alien spacecraft, secret weapons, and almost every other explanation capable of surviving in the space opened by incomplete evidence. These theories are usually more revealing about human psychology than about Siberia. When a real event looks extraordinary enough, ordinary explanations start to feel emotionally insufficient, even when they are scientifically robust. People want the cause to feel as dramatic as the effect. A rocky cosmic intruder exploding high in the atmosphere is already dramatic. But because Tunguska remains slightly out of reach, fringe theories keep crawling back into the gap between probable and proven. Mystery invites imagination. Silence gives it room. One of the most discussed attempts to pin the event to a specific place on the ground involves Lake Checo, a body of water near the blast area that some researchers proposed might be linked to a surviving fragment or delayed impact effect. For a moment, this looked like the kind of clue Tunguska had always denied investigators, a concrete location that might behave like a crater. But the claim remained disputed. Other researchers argued that the lake likely predates 1908 and does not solve the case. This is typical of Tunguska. Every potentially decisive clue seems to arrive already carrying its own counterargument. Even when scientists use modern methods, the site behaves like a puzzle assembled from damaged edges. A promising shape appears. Then the fit loosens again. The forest itself still tells part of the story. Treefall patterns map out an explosion centered above the ground rather than a direct impact into it. Burn patterns, branch stripping, and the strange survival of some central trunks support the idea of a downward blast wave and thermal pulse. Later ecological recovery also provided clues. New growth emerged, altered by the destruction and by the chemistry left behind. Researchers studying soils, peat, and tree rings have looked for traces of extraterrestrial material, isotopic anomalies, and signatures of extreme heat. Some results support a cosmic origin, but not in the kind of spectacular way the public often imagines. Tunguska is not a mystery because science found nothing. It is a mystery because science found many pieces, none of them theatrical enough to silence the others permanently. There is also the problem of scale. Tunguska was large enough to be catastrophic, but small enough to sit in an awkward middle category. It was not a planet-wide extinction event. It did not produce a crater like Barringer in Arizona. It did not announce itself with iron masses scattered everywhere. Instead, it became one of the clearest reminders that the sky can deliver enormous destructive energy without leaving behind the kinds of evidence non-specialists expect. That is what makes Tunguska quietly terrifying. It is not just a historical curiosity. It is a demonstration. A body that never reached the ground intact still flattened a forest on a scale large enough to feel almost unreal. The planet was hit by something that mostly died in the sky, and the sky was still enough. Modern comparisons only sharpen that point. When the Chelyabinsk meteor exploded over Russia in 2013, the event injured more than 1,000 people, mostly through shattered glass, despite the object being much smaller than the Tunguska body. Chelyabinsk gave the modern world dashcam footage, pressure wave analysis, recovered meteorites, and real-time data. It made airbursts feel contemporary rather than antique. And once that happened, Tunguska stopped seeming like a singular myth from a half-documented past. It became a warning with precedent. If a Tunguska-scale explosion happened over a major city today, the destruction would be appalling. Buildings would fail. Glass would become shrapnel. Fires would spread. The death toll could be enormous even without a crater. That modern awareness changes the emotional texture of the old Siberian event. It is no longer only mysterious. It is uncomfortably relevant. The exact altitude of the explosion remains part of the debate because altitude shapes everything: the pressure wave, the heat, the pattern of devastation, and the expected remains. Models often place the main burst several kilometers above the ground, but small changes in speed, angle, density, and fragmentation behavior can alter the details significantly. That is why Tunguska still attracts physicists and planetary defense researchers as much as historians. It is a real-world data point for understanding what near-Earth objects can do when they encounter the atmosphere under extreme conditions. The event matters scientifically not just because it is mysterious, but because it is rare, measurable in fragments, and impossible to rerun. Nature conducted an enormous experiment over Siberia. The instruments were incomplete. The consequences were lasting. The questions are still useful. There is another reason Tunguska resists closure, and it has less to do with the object than with the human need for clean endings. Many historical mysteries eventually shrink as new evidence closes the field of possibilities. Tunguska did that only partway. Scientists are not equally divided between every theory. Some explanations are much stronger than others. Most serious researchers do not think aliens detonated a craft over Siberia. But the stronger the ordinary explanation becomes, the stranger one detail remains: how much devastation could come from an object that left behind so little certainty for the public imagination. We understand the general mechanism. We still do not possess a single cinematic artifact that makes the case feel finished. For historians and scientists, that gap is manageable. For the broader public, it is irresistible. There is also a grim philosophical side to Tunguska that makes it feel darker than a simple meteor story. The event happened by chance over forest rather than overpopulation. That accident spared enormous loss of life, but it also means the disaster entered history with a strange moral emptiness. No army caused it. No state ordered it. No villain can be blamed. It was a purely indifferent catastrophe. Something in space crossed Earth's path, encountered the atmosphere, and turned part of Siberia into a shattered zone because physics permitted it. Human beings are good at processing danger when intention is attached. We can hate an enemy, condemn a murderer, prosecute a conspirator. Tunguska offers none of that comfort. It is destruction without motive. That makes it feel colder than many tragedies that killed more people. The site's remoteness amplifies that coldness. There are no famous stone ruins, no urban skeletons, no iconic crater rim tourists can stand on and say this is where it happened. There is only forest, marsh, scientific reconstruction, old expedition photographs, and the knowledge that something incomprehensibly fast entered the atmosphere above an ordinary landscape. When people look at archival images from early expeditions, the toppled trees seem almost too geometric, too deliberate, as if a giant invisible hand brushed them outward from a center no one fully captured in time. Those images are part of Tunguska's power. They look like evidence from a world briefly touched by something outside ordinary historical scale. Not fantasy. Not myth. Just the brutal encounter between Earth and a moving object from space. That is why the event keeps returning in documentaries, books, scientific papers, and conspiracy culture at the same time. It satisfies two opposite appetites. For science, Tunguska is a valuable natural case study in atmospheric entry, fragmentation, blast effects, and planetary risk. For the imagination, it is a nearly perfect mystery. The evidence is real, dramatic, and incomplete. The witnesses are sincere but distant. The landscape is damaged but not explicit. The leading theory is convincing but still leaves room for the phrase probably. That word matters. Probably is enough for science to move forward. It is never enough for myth to let go. In recent decades, planetary defense programs have made Tunguska newly important. Governments and scientific organizations track near-Earth objects more seriously now because events like Tunguska and Chelyabinsk prove that the threat is not theoretical. Most dangerous objects will never hit Earth. Many small ones burn up harmlessly. But the category that Tunguska belongs to is exactly the category that can still do severe regional damage without being globally catastrophic. That makes it politically and scientifically awkward. It is not the apocalypse, so it is easy to ignore. But it is not trivial either. Tunguska sits in the zone of risk that can flatten a region, devastate a city, and remain just rare enough that people forget about it until the sky reminds them. Some mysteries survive because there is no good explanation. Tunguska survives for the opposite reason. The explanation is good, but the event is so visually and psychologically extreme that the explanation never feels as complete as people want it to feel. An asteroid airburst sounds neat on paper. It does not fully absorb the image of a morning sky erupting above Siberia, the forests falling outward like matchsticks, the nights glowing strangely far away, and investigators arriving years later to study a wound whose author had already vanished. Science can model that sequence. It cannot make it feel ordinary. Tunguska will probably never become ordinary. And perhaps that is the most honest reason it still haunts people. The Tunguska Event sits at the edge of two different forms of knowledge. On one side is calculation, trajectories, blast models, atmospheric physics, impact probabilities, geochemical signatures, and simulations that make the event increasingly legible. On the other side is the older human response to the sky: awe, dread, omen, myth, and the fear that something vast can arrive without warning. Most of the time, modern life lives on the first side. Tunguska forces a meeting with the second. It reminds us that history is not shaped only by kings, empires, and wars. Sometimes history is shaped by a stone or an icy body from the dark, arriving at cosmic speed, choosing no target, and still leaving behind a scar large enough for generations to keep asking the same question. What exploded over Tunguska in 1908? The strongest answer is that a cosmic object burst in the atmosphere and unleashed the energy that flattened the forest below. But that is not the same as knowing every final detail of its composition, breakup, trajectory, and surviving traces. The case remains open in the narrow but compelling way that the best historical mysteries remain open. Not because nothing is known, but because what is known keeps circling an absence it cannot completely fill. Tunguska left no villain, no confession, no treasure chamber, no intact relic. It left a pattern of ruin, a century of investigation, and a warning. The sky does not need to strike the ground to change history. Sometimes it only needs to come close. Subscribe to Shadow Archive for more dark history documentaries.